Hi everyone. So in last classes, last two classes, we are just studying about the properties of periodic table. So in that regard, we have already completed the two properties: atomic radius as well as ionization enthalpy or energy. So today during this class, we will deal with the one more property, that is electronegativity. So students, electronegativity will be very important for your organic reactions. So and not only for the organic reactions, it will be having a very good scope in chemistry. And if you come to know about the electronegativity, then it will be very easy for you uh, to understand where the shared electrons are moving and why they are moving. So let me define first what is electronegativity. So electronegativity is nothing but the ability of an element to attract shared electrons. What is shared? I will write it. The ability of element to attract shared electron towards itself. Right? So now, what are these shared electrons? What are these shared electrons? Which is very important. So ability means to attract. They are attracting the shared pair of electrons. Consider a bond between any two elements. Consider this H and Cl. So here, excuse me, sorry. So now we'll take one more example. We can take. So for understanding purpose, we can take covalently bonded elements like H and H. So therefore, one we can easily understand this concept. So now, for the formation of, see, forget about electronegativity. So just to consider this, for the formation of a single bond between these two hydrogen, this hydrogen might have donated one electron, or this hydrogen might have donated one electron. That means already they have shared their electrons, right? So already shared electron, the ability of element to attract already shared electron. If these shared electrons are attracted by the atom, any atom you can say. Later we will see what is electronegativity. What type of element will attract these shared electrons. We just consider as an example, if the already shared electrons are attracted by any element, that ability is nothing but the electronegativity. If already shared electrons are attracted by any element, then that attracted power will come due to this what? Electronegativity. So how this electronegativity varies in case of group as well as in case of period, we will see definitely. But try to understand, if any atom attracts already shared electron, already they have shared for the formation of what? Bond. If those electron also, if the one element is attracting towards itself, then such process is called as electronegativity, right? So see here, electronegativity, one we can explain again on the basis of atomic radius, right? So again, the atomic radius is very important. So that's why in the first class itself I said If you come to know what is atomic radius or how the atomic radius changes in case of group and in case of period, then definitely one you can easily understand these concepts or you can enjoy these concepts, right? So now electronegativity again we will see in case of group as well as in case of period. I won't show any elements, directly we will go in the group. So in group, so definitely what was happening with the atomic radius? Definitely the atomic radius was increasing, right? I repeat again, atomic radius increases in case of what? Group. See dear students, generally you understand, if the atomic radius is increasing means in the last class, I mean in the ionization energy class, what we saw, one we can easily remove that electron. If when there is a large size or the atomic radius is big in the element, then from that element one we can easily remove the electron. Why? Because the distance between the electron and the nucleus is far away from each other. If it is more, I mean the distance is more, then definitely what happens? One we can very easily remove this electron, right? So now whenever there is a loss, see, remember again, during offline classes, we have already saw these concepts, right? How the positive charge will come on the element, how the negative charge will come. So that means, see here, whenever there is a loss, what happens? Definitely the positive charge will come, right? Whenever there is a gain, the extra electron, if the element is gained, then definitely what happens? There the negative charge will come. So these concepts will come. So that's why I am just reminding you, right? So in case of group, the atomic radius increases. If the atomic radius increases, then what happens? The electrons are very easily undergoing into the ionization, right? In group, atomic radius increases, sure, right? So if atomic radius increases by moving from top to bottom in the group, then definitely what happens is, as the size increases, electron will move away and away from the nucleus. If the electron moves away from the nucleus, then it will be very easy to remove it, right? That means in group, very easily one we can remove the electrons. Why? Because the atomic radius is increasing, right? So atomic radius increases means one we can easily remove the electrons. Whenever there is a loss takes place in the element, what happens? Definitely the positive charge will come. Whenever there is a loss in the element, what happens? Definitely the positive or cation formation takes place. So once the cation formation takes place, then what happens? Definitely onto this overall, I mean on this atom, the positive charge will come. If this element is able to acquire a positive charge, then one we cannot call that as an electronegative element, right? Already what it got after loss of electron? Positive charge. If it has already got a positive charge on it, then definitely its electronegativity, what happens? Goes on, decreases, right? What happens? Goes on, decreases due to what? Due to increase in the size. Due to increase in the size, electrons are readily removing, or very easily we are removing the electrons because of distance. Distance is far from nucleus and the electron. So that's why one we can easily remove the electrons. If we are able to remove the electrons, then definitely whenever there is a loss, already we have discussed during the offline classes, what happens? That element will be able to get positive charge. That means positive charge is dead opposite of negative charge. So that means what happens? In group, electronegativity decreases, right? In group, electronegativity decreases. Reason is very simple. Again, you can go with the due to increase in what? Due to increase in atomic radius. So in case of group, the atomic radius increases. So that's why element can lose very easily electron from the valence shell. So if they are able to remove the electron very easily, then definitely the positive charge will come. If the positive charge will come means there is no doubt of electronegativity. So thus, in case of group, always the electronegativity decreases. Right? This is one case. So now let us move towards the periods. So in period, what happens? If it is increasing, if it is decreasing in case of group means, definitely in case of periods, what happens? It will always increases. But our duty is to see how this will increase, right? So now again go to the atomic radius. In period, atomic radius what happens? Goes on decreases. If it is decreasing means what happens? The distance between nucleus and the valence shell electron decreases. If the distance between nucleus and the valence shell electron decreases means definitely it will be very difficult for us to remove the valence shell electron. Why? Because as the electron comes nearer to the nucleus, it will be very difficult for us to remove. Why? Because as it comes nearer to the nucleus, the strong bond formation takes place between nucleus and the valence shell electron. Once the strong bond formation takes place, then very simple we can say it will be very difficult for us to remove the electron. So that means in a period, atomic radius is definitely decreasing. If the atomic radius decreases means, see, now for me in the period, it is very difficult to remove the electron. Why? Because as we are moving in the period of a periodic table, then what was happening while moving from left to right in the period by element, then the size was decreasing. Size is decreasing. So if the size decreases, then strong bond formation takes place between these two, nucleus and the electron. And if once the strong bond has formed, then it will be very difficult for us to remove. If we are unable to remove the electron from the valence shell, right? If we are unable to remove the electron from the valence shell, then what happens? The negative character will retain on that particular element. If the element is able to retain the negative charge, electron, then what happens is the electronegativity character increases, right? Electronegativity character increases. Why? Because the distance was very near, and the outer electron, if the electrons are shared already, then see this much only the size of a element. If the size is this much, then this nucleus can drag these electrons towards itself very easily. So that's why these type of elements, that means very simply we can say those elements having their size less, they are more electronegative. Those elements having their size less or atomic size less, then those are called as more electronegative elements. Why? Because if the size is less, then it is very easy for that particular element to drag the already shared electrons. Like this I was discussed before only, right? So if this electron has shared one electron means this hydrogen also has shared one electron. So any element, if they have ability to drag these shared pair of electron towards or attract these shared pair of electron towards themselves, then those elements or those atoms are called as strong electronegative elements. And electronegativity increases as the size decreases. And the decrease in the size, one we can see in case of period. So already during that class I have explained. So lithium, beryllium, boron, carbon, nitrogen, oxygen and the fluorine. So that means while moving from lithium to beryllium, size decreases. From beryllium to boron, again the size decreases, like boron to carbon, carbon to nitrogen, or nitrogen to oxygen, or finally oxygen to fluorine. Definitely the size will decreases. If the size decreases, then electronegative character definitely increases. If the electronegative character increases, then these elements can drag already shared electron towards themselves, right? So carbon, yeah, I mean, if I compare, see here, lithium is less electronegative than the beryllium. Beryllium is less electronegative than the boron. Likewise, boron is less electronegative than carbon. Carbon is less electronegative than nitrogen. Nitrogen is again less electronegative than the oxygen. And oxygen is less electronegative than the fluorine. And here the most important part is fluorine. Fluorine is the one element which is having a more electro or strongest electronegative character element is what? Fluorine. Why? Because its size is very less. So why this is increasing means, as we are moving from lithium to beryllium, the size is decreasing. As I said, as the size decreases, definitely what happens? Electronegativity character increases, right? So electronegativity character increases. That means in a period electronegativity increases. So the reason is due to decrease in atomic radius. Due to decrease in atomic radius. So this is all about for today's class. So if you are not getting, please go through once. Why? Because they are interlinked. If you understand, if you are able to understand the atomic radius, then definitely one you can understand the later properties like ionization enthalpy or electronegativity. So in this is all about today's class. In the next class we will see one more property like metallic and non-metallic. We will complete it in single class, right? Thank you.